Well, hello and welcome to this new tutorial series on OpenCV. So in this, we will see how we can use OpenCV for different applications of computer vision and image processing. So first of all, we will get started with the setting up our development environment, and I'll be using Anaconda. So I'll show you how to install Anaconda and then OpenCV. And of course, if you want to work with any other IDE, you can also use that. And then we will start doing something with OpenCV, specifically how we can read, write, and display images. So let's start with the setting up of our environment. First thing I will do is to go and download Anaconda. So you can search this one in Google, go to this Anaconda, and there are various editions are available products, and if you want to use any of them, the individual version, that edition that I want to use it is for free. So you can click on this download, and from here you can use any of your operating systems, including the Windows, Mac, or Linux. So since I'm using the Windows, so I will be specifically using the 64-bit edition, and if you're using 32-bit, then you can install for the 32-bit. And remember that this one is by default using Python 3.8. So you can click on it, download it, and you can double click on this one and start installing. By the way, since I have already installed it, so I'm going to cancel it. Just you need to start it. Once you start this exif file, then you will have almost some similar interface like this. You need to click on next. I agree. If you do agree, you can select any of them, it doesn't matter. And you can select any of the locations that you want to install. And there are two possibilities. Either you want to check add this Anaconda to the environment variable, or if you don't want, but this is the recommended one, but I selected the not recommended one, so I just added this one, clicked, checked it, and then installation. That's it. You don't need to do anything. If you want to install Microsoft Visual Studio Code, then you can click it. Otherwise, you have to skip it, and that's it. So installation of the Anaconda is very simple, and I hope you can easily do that. So once we have the Anaconda, we can go and launch the Anaconda Navigator. So you can click on this Anaconda Navigator. Okay, so this is the Anaconda Navigator. From here you can select any of the applications, that actually different applications you can see you want. But this is the base root directory. So what I personally prefer is to create a new virtual environment for Anaconda, and there I can install, update, delete, or whatever I want to do with the packages. So that is what I prefer personally. So your other packages will not be affected. So what I will do is, the first thing that I will do is to create a virtual environment, new one. You can use this environment, and you can also create a new virtual environment also, but I would not recommend it, or I will not prefer to use it. In fact, what we can do is we can use any command prompt. We can launch it command prompt or the command PowerShell, any of that you want. Let's say I just want to launch this from here, and we can write a command. And remember that this is in the base. It is opening in the base. So what I will do, I want to create a new virtual environment. So what we can write is this command, conda create, means we are going to create a new virtual environment. Dash n means what will be the name. Let's say I write it Python 3.8. It means this is the name of my new virtual environment. And if you want to set a specific version of Python, then you can also write, for example, 3.8. And if it is 3.8 is the default, you don't need to mention. But if you want a specific one, I would like to write it like Python 3. Is equal to, without any space, 3.8. Followed by, now I just not only just want to create a virtual environment using Python 3.8, but I want to create an Anaconda environment where default packages will be installed. So I will write Anaconda, remember that. And once you enter it, it will create, it will take some time and it will create a new virtual environment for you. So I already created a new virtual environment. So, and my virtual environment name is also like Python 3.8 or something. So this way you will able to create a new virtual environment. So once you create new virtual environments, you should be able to see those virtual environments in the application on. So here you can see I created two virtual environments, Py 3.7 and a Py 3.8. So now I just want to use Py 3.8, which is basically uses Python version 3.8. So you can click on this Py 3.8. So this one navigator will load all the packages and all the stuff present in that virtual environment. And so one thing also remember, now when I click on the launch, then you will see that this will be going to, if I install anything, so this is going to install in Py 3.8 virtual environment. Remember that. We need to install the OpenCV also. So again, I'm going to launch this PowerShell prompt. And when you go there, Python OpenCV Anaconda, and then you can go to OpenCV Anaconda, and this one will show you the command to install it. So you have to copy this one of these commands. So I'm just going to select the first command, conda install -c conda-forge OpenCV. And remember that the version of OpenCV that currently on Anaconda is 4.5.2. So I'm just going to go ahead and install it. So I'm just copy it, paste it here, and this one will take a little bit time. So in the meantime, I will pause the video and will resume it once it is completed. And here you can say yes if you want. Okay, it is done, and in your case it might take some time because I already had this version of Python OpenCV, so it is just updated and it's okay. Now we are pretty much ready to launch it. So I'm going to use JuypterLab for learning. It is the best one, and if you want to use Visual Studios, I have already installed it. You can also launch Visual Studios from here. If you have PyCharm already installed, you can also launch it. If it is not installed, and if you want to install it, then it will show something like this, installed. You can use this Anaconda Navigator to install it even. And if you want to work with Jupyter or Spider or whichever you feel comfortable or Studio, you can work with it. So the simplest and the powerful is the JuypterLab, and which will help us to learn OpenCV. So I'm going to click on this launch. Okay, so the JuypterLab is launched now. I'm going to close these extra tabs, and here you can see I have created a lot of actually stuff folders. So in your case it might be blank, it's not an issue. So let me go and basically create a new folder where I will be putting all my code. So I'm just going to click on this new folder, and you can give, for example, tutorial OpenCV. So I'm just double clicking on it, and inside it, as you can see, it's quite blank and there's nothing inside it. What I will do, and also in your case you might not have Python 3.8 xPython or xPython. This is later we may show you for debugging, we may need it. So in your case you can just launch Python 3 notebook, and I'm just going to click on it, and this one just created a new untitled IPython, and it will save it, but I just want to rename it. So right click on this one, and I want to give this name is tutorial number introduction. So this is the introduction by IPython. So the first thing that, as you can see here, from here we can select any of the kernels if you want to not select it, or if you want to select that. So by default is the Python 3 interpreter that we have. If we want to write a markdown or a raw or a code to execute this one, this cell, the current cell, and then stop execution. If you want to copy a cell, cut it, all these are available here. If you want to close the tabs and all these options, if you want to download or export this notebook as in the form of any of these, you can do that. You can shut down your kernel. Some editing options, as you can see here, for undo we will select Control and Z, Control Shift, copy paste, all these stuff shortcuts we will see anyways. So when you go to opencv.org, you will see a journal introduction to OpenCV. It is one of the biggest open source library for computer vision. It has a very good documentation available online. The tutorials are also available. We have some courses, and it can be used, and it has been used in many applications. So the current version, as you can see, 4.5.2, and there are the main modules. You can see uh, the core functionalities and the image processing, which we will be focusing most of in this tutorial. We can have the video input output, images, video analytics, and the object detection, neural networks, machine learning, and all those stuff, and the some extra modules which are also contributions for many scientists are also present there. So we can just start with how we can read an image, how we can display an image, and how we can write an image. So in order to use the OpenCV, the one thing that we need to do is to write the import CV2. So this one will basically import the CV, and then we can use it. So computer vision library is imported, so all the functionality can be accessed. Now we can read any of the images. So the better thing could be to create a new folder and put all those images here. So what I will do, I'm going to create a new folder and call it data, and click on that, and I can import and drag and drop an image. I have an image, and I'm just going to drag and drop it here. So this image is present here, and this is inside this data folder. So these are not in the same location, as you can see. So I'm going to read it and put it in a variable called image. So I will be using cv2.imread, and here I need to put a path. So / means there is a folder called data, and inside this data there is an image called lena.jpg. So we can see here img.shape. This one will tell us what is the dimension of this image. So you can see that this is basically a 225 by 225, and it is a colored channel. We can display it using imshow. So cv2.im, and when you press tab, this will show you the suggestions, and then when you click on tab, it will select enter, and then you will select. Another thing, when you click on shift in the tab, this one will show you the parameters of the function, any function. So this one says we have two parameters. You need to provide a window name. So I'm just calling it image, and then we need to provide this img. So when we want to show it, so it will be waiting, it will not show actually. So what I will do, cv2.wait key. This is important, so that it is waiting for some key, and 0 means it will be waiting for infinite time until it is closed, and then we can destroy the window if it has created. Destroy window, we can write STORY, all windows, and then you can enter and then close that. So let us run this, shift and enter, or if you want you can press this start button also. So here is the first output that we can see here. The Lena image has been displayed. One more thing that we need to notice when we write, let me comment it, control and a slash. So if I want to read this cv2 dot imread and click on tab, so it will complete it. And when I click on shift and tab, then you can see there is a file name. It is mandatory that we need to provide, and then there is a flag. So what this flag is actually doing is to that specify how the input image is read. So if we want to provide that flag, so the first thing will be the string. I'm just going to copy the same string. I want to read it and put it here. And the second one, we can provide the cv2.im read, and when you click on tab, it will give you suggestion. So any color, or means you can read in any color, any depth. If you want to read the color image, which is basically the default value, so it does just reads the image, and the transparency will be you know ignored, so you need to check it. And if you do it, if you want to read with the transparency, and if you don't want to remove that one, then you can select the unchanged image. If you are reading a JPG image, you must use this unchanged so that the transparency will be also read. For example, if I want to read it as a grayscale image, so we can also do that. So in that case, I select imcv2.imread underscore grayscale. So if it is a color image, doesn't matter, it will convert it into a grayscale. So what does the grayscale means? Let us see it again. Shift and enter. So now you can see it is not a color image. In fact, it read it as basically a grayscale image. And also, if you want, we can also provide this one as integer value. So instead of, for example, I just want to copy it, this line, Control C, and a control slash to comment it, and again I paste it. We can use the integer numbers also. For example, 0 for basically grayscale mode, 1 for the color mode. So when I do this 0 and then run it, you can see the same result. So it doesn't matter whichever you want to use. So this is how we read the image and display them. Apart from using this cv.imshow, we can also display within this JuypterLab. So we may use this Matplotlib, which is already installed as part of this Anaconda. So first I'm going to use import matplotlib.pyplot as plt, for example. And then we can use this plt.im tab, then it will show you imshow is also, it has an imshow enter, and we can display an image here. So I'm just going to pass this img, and don't forget to just use show, otherwise you will not be able to see the image. So when we click on shift and enter, so this one is displaying this image, but this is in a different color. So we can solve this. What is the problem is default when we read this image using EMGUCV, this OpenCV, it reads the image in this order actually. Blue, green, and red. This is the order of the channels. And this imshow is expecting basically the image in RGB order. So to solve this, what we can do is we can convert this IMG from BGR into RGB space. So we can use something like here, I can call it RGB is equal to CV2 dot CVT color. So CVT color, and when you click on shift and the tab, this one is suggesting you what is the source image and what is the code that we want to convert. And you can see the description here also. So I want to convert this IMG, and what I want to do is IMG cv2.color, because we are going to color conversion. When you click on tab, then this one tells you from where to where we want. So color underscore, we have a BGR image and I want to convert it into RGB. So this is what I selected. And now I can display this RGB if I want. And then shift enter. So now you can see here that this is the color image, but since I read it as a grayscale image, so I just want to read it again. So I'm just going to comment it here. In fact, I can write it here. This was the grayscale image. I want to read it as grayscale. And this one I want to uncomment, so I want to display the color image. Okay, I run that, so I store the value in img, and when I convert it, now you can see here that we displayed it correctly in this using Matplotlib. One more thing that we can see here is there is the axis. We don't want to show the axis. So if you want to turn off that axis, we can use plt.axis axis, and we want to set it to be off. And when I click on shift and enter, now you can see the original image. And this is how we can use the Matplotlib to display the color images or grayscale images, doesn't matter. And if you want to show the BGR images in RGB format. By the way, one more thing that you should notice, that when I read the image in this RGB, so we can call it a gray, let's say gray image. If I want to display that grayscale image, and if I use directly the gray, now you can see that it is thinking it is a 3-channel image, and it thinks like it should be RGB. So one thing we can mention here is CMAP, means color map is equal to, when we say gray, then it will display it in a grayscale image. So this is how we can display it, and we will see many things that we can do with the images. And the next thing, if you want to write these images back into a disk, so we can easily do that. And this is the code block. And if you want to create, for example, if I after this one, when I select this and when I click a B, means it will create a cell below, and I would like to write it reading images in OpenCV, and I want to make it as a markdown, and this indicates how big I just want, and shift enter, so this will be generated as a markdown. And if you want a smaller one, maybe you can increase it up to 6, so this one has become a smaller heading. Now I just want to display write images to disk, and I just click on escape, and then M means markdown. It has been converted into markdown, and then shift enter. So this is a markdown here. Now to write it, it's very easy. We will be writing cv2.imwrite function. So here it is, what image, I means image, and when you click on shift tab, you can see here you need to give a file name actually. So what you actually want to store, and then you also need to provide which one you want to store. So the first thing that I want to do is I want to store it in my data folder, and I give it the name. Dot means current folder, slash data means inside this data folder, and here I just want to write it output.jpg, and the image that I want to save is this img, and then shift and enter. So this one is basically returning a true. It means that the image has been saved. We can go here, and then we can see the image has been read. By the way, we can read this image again. img is equal to cv2.imread, if it is okay or not, and then we can read this image dot same image. So I'm just going to read, copy it, paste it here, and then copy the same thing again, because we will be doing the exactly same. So paste it here, and this one should be img. And then now I want to show this img, not the color map, it should be the same. So I'm just going to run again. In fact, it should be RGB. And once we do that, so you can see that we write the image and we read it again. So it is the same image. So this is how we can read, write, and show images using OpenCV. So let's see how we can do further things in upcoming videos. And I hope to see you.